everyone. Thanks for coming to my talk. This is Composing an API the Right Way. We're going to talk about Compose API design today. My name is Márton Braun, and I'm a developer advocate at JetBrains. So this talk is for API designers, and I really believe that everyone writing code is an API designer. Whether you are writing some kind of foundational framework, whether you're working on like framework code, whether you're building a library that others will consume, or just developing an application, you are constantly designing APIs as you write your code. And how important your API design is will, of course, depend on which of these layers you're working in. But it is important across all of the layers. But of course, it's more important if you're working on something more foundational, more on the framework layer or on the library layer, or even in an application, if you're working on like a core module that a lot of feature modules are going to build upon, you have a lot of consumers within your own team, you need to be more careful about how you build your APIs. So this talk is going to be a summary of some documents that Google has published. Excellent engineers at Google have written these guidelines. There are two huge documents in the Android X repo. It's about 13,000 words. It takes a couple hours to read through. It's really, really detailed, excellent quality technical documentation, but it's also a lot of technical documentation. So I'll try to give you like a 40-minute summary of what's in there. Of course, these guidelines are for Jetpack Compose, which is what Google is working on, but I'll give you a bit of a hint here that everything about Compose APIs for Jetpack Compose will also automatically apply to Compose Multiplatform, which we at JetBrains are building on top of Jetpack Compose, expanding the use of the same APIs and the same UI framework to multiple platforms. More specifically, this is currently in beta on iOS as of this year. On Android, it's of course stable because we are reusing Jetpack Compose as is. It's also been stable on desktop for quite some time now. If you use JetBrains Toolbox to manage your IDEs, then that's actually a Compose desktop application. And we also have a web target, which is currently in alpha. So a very quick overview of some of the topics we're going to cover today. We're going to talk about naming a bit first, then we'll look at various types of parameters, highlighting some Compose-specific things like modifiers and slots, and then we'll have a bunch of things around the state handling to wrap things up with. So, starting with naming. How does Compose name its constants? Here's the naming convention that Kotlin has, if you read the just Kotlin coding guidelines, which is the same convention that Java used to have for static values, right? This shouting case, all uppercase with underscores separating the words, but Compose doesn't actually use this convention. Compose breaks convention with this basic guideline, and instead they use this kind of formatting for constant values. They use this upper camel case format. And not only do they do that for actual constant values, but they also do that for properties that are not necessarily marked as const, but are semantically the same. And of course, things like objects also kind of have the same semantic meaning. It's one reliable value, which is stable over time. And the same is actually true for enums, where again, the naming convention would be different, but Compose chooses to use the same naming style for each of these different types of constant type values, because semantically as a user, you shouldn't care about whether you're grabbing an object or the value of just a package level property. What you care about is how it behaves. So what about functions then? How do we name composable functions? Well, it really depends. There are actually two big categories of composable functions. There are those that emit some content, and there are those that return a value, and never the twain shall meet. So you really should have composable functions that fit clearly into one of these categories, as we'll explore a bit later. So on the left-hand side, those that emit content, we have examples like all of the UI things, so button, column, as well as UI related but not actually visible on the UI things, such as a launch effect. All of these are entities in your application. As a result of calling these functions, something will exist as part of your application, as part of your composition. These functions will emit nodes into your Compose UI tree. So these kind of have formatting which makes them look a bit like constructor calls, if you think about it, with the uppercase naming of these functions. And of course, all of these, because they are entities, all of these are nouns as well. So it's a button, it's a column, and so on. On the other hand, we have those composable functions that return a value for you to use. Here, for example, we can look at something like string resource or remember scroll state. These functions mostly use the composable annotation because they need to grab something from the composable context. So they depend on some composition local values or something like that. Speaking of these functions, it might be tempting to use the Kotlin convention where you have these factory functions where the name of the function is the same as the type you're returning. So these like virtual constructors, if you will. But this is actually something you should not do in Compose, exactly because of what we've just seen on the previous slide. So if you have a composable function that returns a value and that's its purpose, it doesn't emit things into the composition, you should stick to lowercase naming with that. And especially if you have a composable function that does some extra work. For example, it also remembers the value for you internally. So on the call side, you don't have to wrap it into a remember anymore. You should also indicate that and use a correct prefix for it. At this point, I want to create a definition here for a component. The guidelines use 2 or 3 different but very similar phrases or words for this. I'm going to call these components. And I'm going to say that a component is a composable function that returns a unit and emits exactly one compose UI3 node. And let's take a look at some of those things in that sentence. So first of all, why should UI components and components in Compose emit exactly one compose node? Well, whenever you write composable code, you are building trees, essentially. So here, for example, we have a small basic compose snippet, and this maps to a tree in Compose. So in the root, we have a column. It has 3 children. It has a text, and a row, and then the row has more children, and so on. And the great thing about Compose that we love about it is that it's all Kotlin, right? So writing Compose code is just editing Kotlin code, and whatever you can do with other Kotlin code, you can also do with composable UI code. For example, you can take a look at some arbitrary piece of your UI and decide to refactor that and move it into a separate function, and then just call that function where those calls used to be, and you have, successfully extracted some of your UI. The problem with this is that you should be a bit careful about how you extract these components specifically, because right now we have managed to create a composable here that doesn't have a single root that it emits. It emits actually 2 nodes into the composition. So there's like a missing root here for this composable. And having composables like this is a great way to have this kind of problem, where in lack of the proper context that these text calls used to be inside of some specific layout, if you don't have that layout available, surrounding the call to the title function, then you might have these kinds of rendering issues. And the fix for this is, again, to make sure that each of your composable components are nice self-sufficient components that can be reused in multiple places in your application. And the way to do that is make sure that they have a single root. In that case, in the case of this function, we could, for example, wrap it inside a column, and then we would make sure that wherever it's being used, it will display correctly. One of the other things we had in this definition was that these composable functions should return a unit. So let's talk a bit about why, in the case of components, we don't want them to be returning meaningful values. If you're coming from writing imperative code before Compose, it can be quite tempting to try to create a function such as this input field here, which not only displays something on the UI, but also returns an object, which is kind of a handle to the state of that input field. This has multiple problems. One of them is the problem of who owns this state, because this function has created that state internally, so it might well be able to modify it potentially. So that function itself kind of owns that state, but it also returned that state for us to use, so we also get to modify it externally. So it's not clear who's supposed to manage this state exactly. And then there is also a more practical problem with this. If you take a look at the code snippet that is trying to use this input field, we are going to have ordering problems very quickly if we start creating components like this. We have this button here, for example, which is trying to clear the value of the input field. And if we just rearrange our UI a bit, if we just want to move that button above the input field, we no longer have the input state available, right? Like that would be like very annoying as you're writing your application. So instead of this, what you're supposed to do is feed this kind of state into your components so that you are driving them externally. And this way you get to decide where exactly you instantiate the state. You can lift it to whichever part of your application you want to place it in. And then you can make sure that it's going to be available to use wherever necessary, in the input field, in the button, and so on. And of course, it's also clear this time around that the input field itself does not own that state anymore. And yeah, we can now arbitrarily reorder things. And this is one of the basic things that we have with declarative UI, right? Like if you've seen an introductory Compose talk, you might have seen some graphic resembling this. These functions take data as inputs and they transform those into UI. That's the purpose of composable functions. And the way that we pass in data is, of course, through parameters. So we're going to explore those a bit in the next section here. Before we look at parameters, I want to look at the alternative, basically, which is going to be composition locals. I have a link here, and I'm going to have a bunch of links during the talk. I'll also have all of these collected at the end, so you don't need to grab each of them individually. So composition locals are a way of exposing a value at some point in your Compose UI tree, and then anything that's nested under that is going to have access to that value that you've placed into the composition. We're not going to go down to the API level, just a high-level overview. So any of those nodes that are nested within that subtree can just reach out and grab that value magically without, actually receiving it as a parameter. And the guidelines say that this is fine to do for really, truly global concerns such as styling, where you don't want to pass styling parameters to every single one of your composable components, but it's nice to be able to control it at the root of the application to switch something like dark or light theme and so on. But you really shouldn't use this to pass down data because it, again, creates components that are not self-sufficient. So if one of these nodes needs to always have a specific other parent node in the composition that will provide it with data to display, that component is going to be very hard to reuse in other parts of your application. So in general, Compose prefers using explicit parameters over using the implicit workings of composition locals. Something that exists in Kotlin that Compose makes great use of is default arguments. You see this all over Compose code. Here we have a basic example of a text component. And as you can see, it has a lot of default arguments, which means that while it has a lot of customization, you can also just call it by passing in a single string, and that will already give you something that works on its own. Looking at this signature, we also see something that's an example of using composition local values very nicely. So here we are grabbing some styling information from a composition local value, but we are not hard-coding that in the text. We are using that as a default value for a parameter. So by default, it will grab that from the composition. But as the user, you can also choose to just pass in your own value if you want to customize the behavior. I want to point out a possible anti-pattern here as well. It might be tempting to use a null value as a marker in your parameter list, which just means that this value has not been set, and then inside your implementation resolves it like default to some other value, for example, that composition local that we've just seen. But you should really not do this. You shouldn't use null as a marker of an unset value. You should really only use null as a default argument if it means the absence of something. And if we hop over to the button composable, we actually see a correct use of that. Here, null actually means that the button should not have a border. It doesn't mean, a parameter has not been passed in, resolve it to something else. It means no border. It's the absence of that value. So this is how you use null correctly. And while we're here, we can also observe something else that button is doing, which is that it has a lot of different default values, and all of these are organized into this button defaults object. If we take a look, this object includes a bunch of different sizing information. It has a shape in there. It has some utility functions to create the default values of button-related types. And this is actually really useful because as a caller, you can reuse these default values in certain scenarios. For example, let's say that you're trying to use this button component, and in some cases, you have custom colors coming in from some parameters, but you don't always have that. So in case that's a null value, you want to default back to the original colors of the button. And because this button defaults object exists, and it's nicely prepared for you to use, you can just refer to the button colors that are stored in that defaults object instead of trying to, dig down into the button implementation and maybe copy the exact colors that were the defaults or something like that. This way, you can just refer to the defaults that the component itself also uses. Importantly, if you're going to provide a component that ships with defaults like this, make sure that you make those APIs public because it's very useful to be able to reuse them. Even though minimizing your API in general is a very, very good idea as you're building a library, these kinds of default values should be provided publicly for your users. This brings us to one of my favorite parts of Compose parameters, which is modifiers. Modifiers are a great way to allow a lot of complex customization with just a single parameter. By just adding a modifier parameter to our composable, we can receive all kinds of customization for sizing, for coloring, for layout, for accessibility, for event handling, and so on, right? So this is very convenient. And because modifiers already cover a lot of customization cases for components, we should not duplicate this as part of our parameter list. For example, we shouldn't provide a separate parameter that also controls padding, because then it's a very confusing API where you can pass in a modifier for padding, or you can pass in the padding value. You should make sure that you're not duplicating anything that's already covered by modifiers anyway. An interesting question to ask as you're designing your components could be whether you should have a modifier parameter at all. That comes up fairly frequently. And the situation with that is that if you don't provide a modifier parameter, your component is still customizable. It's just tedious to do. So for example, with this page title here, I can always just wrap it in a box and then put all of my modifiers on there, and I am achieving the exact same effect. But basically the author of page title is just making it inconvenient to use that component. But of course, if the modifier was just provided by default, the same thing would be a bit nicer on the call side. So a couple of rules around modifiers. In general, nicely designed components should accept a modifier parameter. It should be named modifier by convention. It should be the first optional parameter on the parameter list. It should be applied to the root node, and it should have the default value of modifier. We're going to go through these. So the first two we've kind of already seen. Naming it by convention, again, this helps us have consistency between our components. If you've used some of the built-in APIs from Google, some of the material or foundation things, and you also build your components with the same conventions, it's going to be, of course, easier for everyone to use those components. So it's always good to have like common standards for this. Then we're going to look at parameter ordering here in just a second. But before that, I want to talk about this one, which is that you should apply your modifiers to the root node. So as you have your incoming modifier parameter, whatever is at the root of the component that you are creating, in this case, it's that column over there, that's the component that should have the modifier passed into it. To the external world, whoever is looking at this header component, it looks like a column, it behaves like a column, and if they want to change the background color of it, for example, then that should affect the entire column. Whereas if you apply the modifier somewhere else, for example, on some nested part of your component, then any customization being passed in won't affect the entire component, but just some internal part of it, which would get very confusing. So just to show the correct code again, you should always apply this to the root of your component, which we already know that generally you should have just one root emitted. An interesting scenario is when you conditionally show different UI in your components. So here, for example, based on a Boolean flag, we are either showing our component as a column or as a row. And in this case, we do have to apply the modifier in multiple places. Of course, for any invocation of this component, we will only run into one of these branches. So it's either going to be the first or the second branch. But whatever effectively ends up being the root of our component after all of these conditionals should have the modifier applied to it. We also have this convention of using the default value of modifier, uppercase modifier. So let's take a look at what that means and how that works exactly. So when you write down modifier, just the name of this type, which is an interface, you are actually referencing the companion object of the interface, which itself implements the modifier interface. So the companion object is already an implementation of the interface, and this acts as an empty modifier. So by accepting this as the default value, this is kind of like the null object pattern. It's a modifier that doesn't modify anything, but it's always safe to accept as the default value. And if no other value has been passed in, you can just apply it to your root, and it's going to be essentially a no-op. Now, other than applying it to your root, you might also need other customization added to the root component. So maybe your component needs some padding by default. So to the row that's the root of our component in this sample, we also want to add some padding. And this is perfectly fine to do. You just need to make sure that you take the incoming modifier first, and then you chain any default customization that you want for your component after that modifier. On the other hand, you should never do this the other way around. So you should not have your own modifiers and then put the incoming modifier parameter later down the chain, because this reverses the order of modifiers, and the external customization will be applied before your internal customization, which can, again, lead to a very confusing experience. We're not going to get lost in the details of modifier ordering in this talk, but I will refer you to the official documentation on Compose modifiers, which does a great job of explaining this. All right, another excellent part of using Compose, in my opinion, is slots, which is a really convenient way of passing in UI as parameter to other UI. If you ever had to do this with a view system, accept a view or a view factory or something as a parameter and then attach it to your own view hierarchy with sizing and all that, that was a very painful experience. It was very hard to afford this kind of customization. And in Compose, this is one of the simplest things to do, which is really great. So by slots, we mean parameters that are themselves composable functions, such as this here. And for example, you can use this as the content of a button. This way, the button doesn't have to take a text label and always display that, or doesn't have to take an icon parameter and always display that. Instead, it can take arbitrary UI and any combinations of things you might want to put in buttons from the call site. And all of these things can be supported with just a single parameter. So for example, the call site here could have a row where it passes in both an icon and a piece of text, and all of that will be rendered as part of the button composable. This is a basic usage of slots. You can also do some more exciting things with slots. For example, if generally speaking, your users tend to have the same layout as part of the UI that they pass in. For example, in the case of buttons, they might usually put things inside a row, like we are doing here on the call site. Then you can actually place that row into your implementation and let the call site know that you are already arranging whatever they're passing in into a row. And the way to do that is to, first of all, call that row layout as part of your implementation somewhere, and then also to add the row scope receiver to that composable function. So this indicates to the call site that whatever content they're passing in is going to be used inside of a row. And it also lets them use APIs that are only available when you're inside that layout. For example, the weight modifiers are a good example of this because they don't make sense just in arbitrary places in Compose code. But when you're inside of a row, you can use that modifier to customize how the various elements that you are placing into the row are measured and distributed within the space that the row occupies. An interesting question to ask here would be, we basically have a composable function down here, and it doesn't have one root anymore, but it has two, right? Like, it's a composable function that emits a text and an icon. And in this case, this is actually okay to do. For one, this is not a standalone component. It's not a function that people are going to call in other places. It's a lambda that only exists in this one location. But also, it has the receiver, which is always signaling to us that this will be used inside of a row. So we don't need to worry about whether the icon and text are going to be arranged on top of each other or under each other. We know that it's always going to be side by side because we are inside of this row scope. An interesting consideration about using slots is the lifecycle of that content that you're receiving as a parameter. Here, for example, we have this preference item, which again, based on a Boolean flag, either arranges itself into a row or into a column. And it also uses that slot that was passed in as part of that row or the column. And as time is going on, this preference item may exist for some amount of time. And when it's first created, it will call that content function that will create some UI. It will be displayed. And then as the value of the checked Boolean here changes, it will recompose, it will switch between the two branches of the component, and whenever that happens, it will drop all of the content that was previously created, and it will run that incoming content parameter again to produce the UI again, and attach it in a new location within the UI tree. This is not ideal. We are doing too much work here. We could be reusing those UI nodes that we already have, and luckily for us, there is a super specific API which is designed exactly for this use, which is called movable content off. So if you have this kind of situation where you use the same slot in multiple places and you need to be able to move that content between different branches, for example, you can remember that content wrapped in a movable content off, and calling the return value of that, which is again a composable function, will either create the content for you if it hasn't been created before, or it will take it from the previous place where it existed in the UI tree and it will move it to the new location. So it's a very performant way of moving a slot around. And again, if you want to get a bit lost in the implementation details of this and the variations of this function that exist for even more advanced uses, you can check out this excellent blog post here. All right, let's talk about ordering parameters next. The guidelines, again, tell us a couple things about how we should do this. They tell us that we should have the required parameters at the top of the parameter list. Then these should be followed by the optional parameters, where the first one is always the modifier. And then if we have a trailing lambda, that is the primary content of that composable, then that should be called content, and it should be at the end of the parameter list. So let's take an existing component and try to make sure that it fits the requirements of the guidelines. First, it should have the required parameters at the top of the parameter list. The reason why this guideline exists is that you want to be able to call the component with just its required parameters if you don't need additional customization. In this case, we have 3 required parameters, and we would like to be able to call this component by passing in that boolean and the 2 lambdas such as this. Right now, with the ordering that we have in the parameter list, though, that's not possible because, of course, we are missing that first modifier parameter. By default, parameters are positionally passed in. So if we have some optional parameters at the beginning of the parameter list, then that breaks the idea of being able to pass in just the required ones. So if we just shift those over, we can fix that problem. Of course, you can always use name parameters to work around problems like this, but you should not generally force your users to have to name all of the parameters that they're passing in, even though in the case of something like a boolean, that could be really useful because, of course, it aids readability. All right, next, it should be the optional parameters, which is already true, and the first one is actually already modifier, so we're good on that front as well. But it's worth taking a look at why we have this convention that the first optional parameter should be the modifier. The great thing about that idea is that once you have this basic call to the component that passes in the required parameters, if you want to start customizing that component with a modifier, you don't have to think about naming that parameter or where the modifier goes in the parameter list. You know that if you have passed in the required parameters so far, then adding the next parameter will always be valid because that's always going to be the modifier as long as everyone is following these guidelines. So that's why we put the modifier as the first optional parameter of composable functions. And then finally, if we have a primary piece of UI parameter slot, then we should have that as a trailing lambda so that we have this nice Kotlin syntax where we move that function outside of the regular parentheses of the parameter list, and we can see that visually this tag contains the UI that's going to be embedded inside it. And of course, the convention here is just to call it content. So we can just make that quick fix, rename the variable, and now we have a function that adheres to all of our guidelines. Okay, let's keep moving and talk about state next and how we feed that into composable functions. First, I want to talk about the literal state type in Compose and ask the question of whether it's a good idea to pass in a mutable state object as a parameter to a Compose component. This is not a good idea because once you do this, the ownership of the state gets really muddy again. So in this case, as we are passing in mutable state to this component, we might be mutating that state from the outside, but this component now also has mutable access to its own state, so it can also mutate it internally. So yet again, we lose control of the state, and it gets very complicated to reason about our code. Generally speaking, the pattern we should be using instead is this, where we pass in state as just read-only and plain values so that the component can display it. And then if it does need to modify it, it can request those modifications from us as the callers. And this way, we get to do a lot of customization on this component on the call side. We can do validation of the state changes it wants to do, and so on. An interesting question could be whether it's okay to wrap that incoming state into a read-only state object. This should be safe, right? Because the component is no longer able to modify its own state. It is safe, but it's very inconvenient for callers, so we should still avoid this. For example, imagine that the callers already have a plain float value from somewhere, and you're requiring them to pass in a state of float. That basically will just mean that they need to wrap it into some kind of state object every time, like in a mutable state or something, and then they can pass in the value. So to avoid these kinds of inconveniences on the call side, you should generally also not take states as a parameter. You should just take the plain value like this. Something you might consider as an alternative is taking a lambda that will produce the value that you need in your component. This can give a lot of flexibility for the call site in certain scenarios where it's needed. So they can, of course, pass in constant values still. They can pass in plain values, just a float that they already had from somewhere. And they can also make reads to various kinds of state objects or just other stakeholders. So this gives a lot of flexibility, and it also opens up the possibility of not reading that state straight away in the implementation of your component, but deferring it to later stages of composition, which can be great for certain performance improvements. Ben has written a great blog post about this, which was already 2 years ago, about debugging recomposition, about how differing state reads can actually give you great improvements in performance. Finally, I want to talk a bit about stakeholders here. So as you're creating these components, they have their incoming parameters, which are usually plain values. They might have callbacks where they can signal that they want to change some of their state. And as you're doing this and you're getting a lot of these, the signature of this function can get quite complicated. On the call site, you'll now have to pass in, 4 different values, or 8 or 10 or 20. So it might be a good idea to wrap this up into a single state object that's associated with your composable component. In this example, for example, we can move these 2 values into an interface where both of them can just be mutable variables, and then take an instance of that interface as a parameter to the component so that it can both work with the state and signal that it wants to make changes to it. As you can see, we have a convention for this. The state object here should be named the same as the component with a state suffix. And of course, these should be stable. So whenever there are changes made to this composable state, that should be exposed to the composition. We're not going to dive into stability either in this talk. So here's a link to learn more about that. But on the high level, we should make sure that any implementations of the state holder are compatible with the composed state mechanisms. So they store things, hopefully in composed state, so that whenever it changes, the composition is notified. We can create an implementation for that. So here's a sample implementation for our interface. Again, naming convention, we just have the same thing and an impl. We take values for the defaults, for the initial values as parameters, but we also have defaults so that it's easier to create this object. And then we simply delegate into mutable state of with both of these values. And then to hide this implementation from callers and make it nicer to create it on the call site, we can always wrap this into a factory function, which again, can actually follow the conventions set by Kotlin this time, where it's this like virtual constructor that matches the name. This is fine to do because it's not a composable function. And we can even make it more convenient. We can even use this as the default value that's remembered by default by the component. So if someone just wants to use the component without passing in state, they can do that, but they can also instantiate the state object and then have full control over it. Now, we started this part by having the problem of having 4 parameters to a function, and now we have like 20 lines of code to solve that problem. And obviously, if you're working on the application level, for example, you really don't need to go this far. You can simply create one stateholder class. It can be that one implementation without the interface, without the factory functional and all that. And then later on, if it turns out that you do need multiple implementations of that state, then you can, just extract an interface from that and go from there. But if you are a library, it is worth going through all of those different steps of abstraction, offering the interface so that you can offer a nice default implementation and also leave it open for clients to implement it for themselves. And this really brings us back to where we started the talk. So if you're building a framework, if you're building a library, a core module of an application, all of these things are a lot more important to get right because you're going to have other users. If you're on the other end of the spectrum and you're building app code, you're building code in features, you're a solo developer and you're only designing APIs for yourself to use, it's still nice to follow these conventions, but you can deviate from them without, breaking anyone else's experience too much. So these are not hard rules if you're working on something higher level, but they are still good ideas for consistency. At this point, I want to give a shout out to a talk from this year's Google I/O, which was also about designing composed APIs. This covers a couple of the same ideas, but it also dives into how to design the components initially and how to maintain them over time. So it's still worth catching up with if you have not seen it at I/O. And of course, some of these rules are things that you can just do static checks for. And there is a great repository from the community which has a bunch of these guidelines encoded into lint checks. So things like either emitting content or returning a result. Things like emitting one root node. Things like providing a modifier parameter. You can just set up these lint rules, and that can help you validate this across your codebase automatically so that you don't need to argue about it on code reviews. And with that, we have a wrap for composing an API the right way. Here are all of the resources that I've mentioned along the way. Thank you so much for attending. I'm super happy to take questions here if we have the time. You can find me around the conference. And of course, we have a booth for JetBrains where you can come and talk to us about Kotlin multi-platform, Compose multi-platform, API design, and anything else. Yeah, thank you.